Hi students, welcome to the science class. So in last session you have studied about some properties of the matter, that is the solid, liquid, gases, physical properties of the matter, and also one question arises here: is it the matter is around us, is it is a pure? Then we are going to see the gases around us. Is the gas is pure? So when you are going to buy some particles from the shops, is it a pure material? So when question arises in your mind, when you are going to buy some products from the pack which were made by the pockets, which are comes in the pockets, on the pockets you are going to see some lines, pure material, 100% pure. If you are going to buy salt bucket, on the salt it is written as 100% pure. Is it a salt 100% pure? And also when you are going to buy some the tea powder packets or a coffee powder packets, on the coffee powder packet you are going to see 100% pure coffee, 100% pure tea. Is it a pure? So it is not a pure. Then what it is nothing but the mixture. Then what is meant by the pure here? What it says? So under this chapter, matter around us, we are going to study about what is pure substance, what are mixtures, and types of the mixtures, and also what are solutions here. So what is pure substance? A pure substance is nothing but a substance is said to be pure. A substance is said to be pure, if it consists of same type of particles. So what is pure substance here? If we are going to say some substance, it is a pure. If you are going to say some packet, it is a pure substance packet, then it consists of only same type of the particles. If you are going to consider a tea powder packet, if you are going to say that tea powder packet, it is 100% pure, if and only if it consists of only tea powder. If it consists any other dust materials, then it is not a pure substance, it is a mixture. Have to understood. So if any substance is said to be a pure, if and only if it consists of only same type of the particles. You have to remember here, if the substance doesn't contains the same type of particles, then it will be called it as a mixture. Then what is mixture? So we are going to study the substances which present around us all are called it as a matter. That matter will be divided into two types, that are pure substances and another one is mixtures. We know here what are pure substances. Under the pure substances, we are going to study the pure substances can be classified into elements and compounds. So what are mixtures? So the another one type of the matter here is the mixtures. What are mixtures? Under the mixtures, we are going to study some of the types of the mixture, that is homogeneous mixture and heterogeneous mixture. Then the question arises, what is mixture here? You know already what is pure substance. Then the question arises in your mind, then what is a mixture? A mixture, it is nothing but a mixture is a physical combination of two or more substances. Examples. See, a mixture, it is nothing but it is a substance. Mixture is a physical combination of two or more substances. It is a physical combination of two or more substances. A mixture, it is a physical combination of two or more substances. I am considering here one example: mixture of salt and water. Any example you can take. Mixture of sugar and salt. Mixture of sugar and salt. Here mixture of salt and water, it is a one type of the mixture. It is not a pure substance because the water consists of a salt. If you are going to take a water bottle, it is a pure water bottle. Why? Because it consists of only water molecules, isn't it? If you are going to take a sugar packet, it is a pure sugar packet. Why? Because it only consists of a sugar particles. But when you are going to mix up the water and sugar, then it is called it as a mixture because it is a physical combination of that two substances. Is it clear? So this mixture can be classified into two types based on the substance dissolved in it, how much substance it is dissolved in it, how it is dissolved in it. Homogeneous mixture and a heterogeneous mixture. What is homogeneous mixture and what is heterogeneous mixture? See here, a mixture, homogeneous mixture, it is a mixture in which components of mixture uniformly distributed throughout the mixture. So what is homogeneous mixture here? It is a mixture, it is a type of the mixture in which components of the mixture are uniformly distributed throughout the mixture. The components of the mixture, I am considering one example here, mixture of sugar in water. Mixture of sugar in water, and another one is mixture of water and milk. See here, in this mixture, what are the components here? Sugar. Water contains sugar. Sugar will be dissolved in the water. So if this mixture is said to be homogeneous if and only if the solution, the mixture, the component of that mixture, that is nothing but the sugar, will be uniformly distributed throughout the mixture. That will be uniformly dissolved throughout the mixture. Another one I am example taking here, mixture of water and milk. When you are going to mix the water with the milk, that will be completely mixed up with the water. That the water will be completely mixed up with the milk. That's why we are going to call it as a homogeneous mixture. What it is here is, it is nothing but the components of the mixture are uniformly distributed throughout the mixture. The components of the mixture are uniformly distributed throughout the mixture. Then what is heterogeneous mixture? It is deadly opposite to the homogeneous mixture. It is a type of mixture. It is a mixture in which components of mixture are not uniformly distributed throughout the mixture. For example, mixture of water and oil. Mixture of water and oil. See, what is heterogeneous mixture here? It is a mixture in which component of mixture are not uniformly distributed throughout the mixture. In this mixture, the components of the mixture are not uniformly distributed. For example, I am taking here mixture of water and oil. When you are going to mix up the oil with the water, oil doesn't mix up with the water. That will be float on the surface of the water, isn't it? It will be doesn't mix up completely with the water. It will be flowed on the surface of the water. Therefore, it is a heterogeneous mixture. So, what is heterogeneous mixture here? It is a type of a mixture in which the components of the mixture are not uniformly distributed throughout the mixture. And what is homogeneous mixture? It is a mixture in which the components of the mixture are uniformly distributed throughout the mixture. So under one type we are going to study under the mixture, that is nothing but the solution. Then what is the solution? It is a familiar word to you. What is the solution here? See here, what is a solution? It is a homogeneous mixture. It is a homogeneous mixture of two or more components It is a homogeneous mixture of two or more components in which components are completely dissolved. Completely dissolved in it. Dissolved in it. It is a homogeneous mixture of two or more components in which components are completely dissolved in it. So one example I am taking here, sugar solution, that is I am taking sugar solution in water, or a sugar solution, that is mixture of sugar and water. Mixture of sugar and water. So what is the solution here? It is a homogeneous mixture of two or more components in which components are completely dissolved in it. So the components are completely dissolved. It is a homogeneous mixture. It is nothing but the components are completely dissolved in it. So what is solution here? It is a homogeneous mixture in which two or more components are completely dissolved in it. See, one example I am taking here, the sugar solution. Sugar solution, it is nothing but mixture of sugar and water. It is a solution. So in this sugar solution I am considering here the component which dissolves other component in it. It is called as solvent. See here, in the solution, the component of the solution, in the solution, the component which dissolves other component in it, it is called it as a solvent. I am taking here the sugar solution, mixture of sugar and water. So water dissolves sugar in it. Water dissolves sugar in it. Therefore, the water here is a solvent. In a sugar solution, water, it is a solvent. What is solvent here? The component in which dissolves in other component in it, it is called it as a solvent. The component which dissolves other component in it, it is called it as a solvent. So for example, in a sugar solution, In a sugar solution, water is a solvent. Water is a solvent. Then another one important point here, the component which dissolved in the solvent, the component which dissolved in the solvent, that is called it as a solute. The component which dissolved in a solvent, it is called as solute. See here, a component which dissolved in a solvent, that is called it as a solute. For example, I am taking here the sugar solution. In a sugar solution mixture of sugar and water, here water is a solvent, then the sugar is a solute here, because sugar dissolved in the solvent, that is water. Sugar dissolved in the water, it is considered as a solvent here, and the solute, the sugar, it is called it as a solute here, because sugar dissolved in the water, therefore water is a solvent. Why? Because the water dissolved the sugar in it, therefore the water, it is called it as a solvent, and sugar, it is called it as a solute. So what are the properties of the solution here, and also see the types of the solution first. Types of the solution. What are the types of the solution? Types of the solution. We are going to see three types of the solutions here. Three types of solutions. What are those? First one is solid liquid solution. You have to remember which mixture it is said to be a solution. The homogeneous mixture. Every homogeneous mixture, it is a solution. You have to remember. Solution, it is nothing but it is a homogeneous mixture of two or more components, in which components are completely dissolved in it, isn't it? So in the solutions, we are going to see three types of the solution. The solid liquid solution, it is one type of the solution. For example, for solid liquid solution, it is nothing but the sugar solution or a salt solution. Here sugar is a solid material and water, it is a liquid material. Therefore first type, the solid liquid solution, the example for the solid liquid solution, it is here is sugar solution or a mixture of sugar and water. Second type of solution here, that is liquid gas solution. Liquid gas solution. Liquid gas solution, it is nothing but the mixture of gas and liquid. The homogeneous mixture of gas and liquid, it is nothing but the liquid gas solution. Example for liquid gas solution, it is soda water. Soda water consists of the sum of the gases, and also your cold drinks consist of some of the gases dissolved in it. That is another one example for the liquid gas solution. And third one is gas solution or gas in gas solution. Gas in gas solution. Example for the gas in gas solution, it is nothing but our air. Mixture of air contains large 6 to 7 numbers of gases contains. Our air, it is a mixture of 6 to 7 gases, therefore it is one of the gas in gas solution. These are the three types of the solutions we are going to see. First one is a solid liquid solution, second one is a sugar, that is a liquid gas solution, third one is a gas in gas solution. Then what are the properties of the solution here? See the properties of the solution. Properties of solution. Properties of the solution. First property. What is the first property? A solution is a homogeneous mixture. A solution is a homogeneous mixture. Homogeneous mixture. So the first property of the solution, it is a homogeneous mixture. Homogeneous mixture means all the components of the mixture are uniformly distributed throughout the mixture. The second property, the particles of a solution, the particles of a solution, the particles of a solution cannot seen by naked eyes. Cannot seen by naked eyes. So second property, it is the particles of a solution. See, the second property of the solution, it is the particles of a solution cannot seen by the naked eyes. Consider one example here. If you are going to mix up the tea powder with the water, after the stirring, you are going to see the tea particles present in the water. It is not completely mixed up with the water. It is not completely dissolved with the water. You are going to see the tea particles present in the water, isn't it? Is it completely mixed up with the water? So therefore it is not a solution. What is the property of the solution here? It is when you are going to see the particles after dissolve in the water, or when you are going to see the solute particles in the solvent, any solute particles in the solvent by the naked eyes. It can't be seen by the naked eyes. We are not going to see any particles which are dissolved in the solvent. Then that type of the solution, that type of the mixture, it is said to be a solution. That is another one property of the solution. Then third property of the solution. What is the third property of the solution here? Is a solution does not scatter. A solution does not scatter ray of light. A solution does not scatter ray of light. See, I am saying another one activity I am considering here. Take a small glass, it will be a transparent glass, pour water into it and place some wood powder, that is a sawdust. You have to place some sawdust into the water and place it into a dark room. And take a torchlight, pass the light through that glass. Take a torchlight, pass the light through that glass. You are going to see the shining of the saw particles. You are going to see the shining of the saw particles which are present in the water. So why? Because it scatters the ray of light. The particles are not completely dissolved in it. The first thing is the saw particles or the sawdust that is not completely dissolved in the water, that will be present everywhere in the water. It will be seen by the naked eyes. So when you are going to pass the light through that glass, the sawdust, it is going to be scatters the ray of light. Then it is going to say it is not a solution. What is the property of the solution here? A solution does not scatter the ray of light. You are consider another one example here. Mix up the salt particles with the water. You have to pour some 10 grams of salt into the 100 ml of water, completely dissolved in it. After onwards we have to pass the ray of light. Is it scatters the ray of light? Is it you are going to see the particles, the salt particles in the water? It is not seen by our naked eyes. The salt particles are completely dissolved in it and it doesn't scatters the ray of light. Therefore it is a solution. So what is the property of the solution here? A solution does not scatter a ray of light. So when you are going to passes the ray of light through the mixture of sawdust and the water, the sawdust is going to be scatter the ray of light, because the sawdust, it is not completely dissolved in the water. But when you are going to mix up the salt with the water, you are not going to see any the deflection, that is any scattering of the ray of light through the sugar salt solution. Why? Because salt is completely dissolved in it. So another one property of the solution it is here, a solution does not scatter a ray of light when it is passes through it. So another one property of a solution here, the solute particles cannot be separated by the filtration. A solute particles cannot be separated by filtration. So when you have two glasses now, in the last activity you have the two glasses, one is the water contains sawdust, another one is water contains salt particles, that is salt is dissolved in it. So if you are going to filter the mixture of sawdust and the water with the filter particle or any filter equipment, you are going to easily filter out, easily get back, you are easily differentiate, or you are easily separate the saw particles from the water, but you are not easily going to separate the salt particles which are dissolved in the water. What it means here is, in the solute the particles cannot be separated by a filtration. So when the mixture it is going to be called it as a solution, the solute particles which are dissolved in it, that are not can be separated by the filtration. You have to remember. So why I am not call it as the mixture of water and sawdust, it is not a solution, because the sawdust can be easily separated by the filtration, but the salt particles which are dissolved in the water, that cannot be separated by the filtration process. So another one property of the solution here, the solute particles which are dissolved in the solution cannot be separated by the filtration. Then another one property, the solute particles do not settle down, if you left undisturbed. So if you are going to put that two mixtures, that is the mixture of sawdust and water and a mixture of salt and water, if you are going to keep, if you are going to left that two glasses left for 5 to 10 minutes or for a long time, for 1 hour, the sawdust particles which are present in the water can be settled down, but the salt particles which are dissolved in the water can't settle down at the bottom of the glass. Why? Because the solution, the salt particles are completely dissolved in the water. Here the sawdust, it is not dissolved in the water. So another one property of the solution here, the solute particles in the in the mixture of the sawdust and the water, sawdust it is a solute particle, it is not a solution. Why? Because the sawdust will be going to be settled down if you are going to left that glass for 1 hour or 5 to 10 minutes, because it is not completely dissolved. But when you are going to left the glass which contains the salt solution in it, the salt particles doesn't left, that they are doesn't comes to bottom, they are doesn't comes to settle down at the bottom. Why? Because they are completely dissolved in it. So under one property of the solution here, that is the solute particles are doesn't settle down if you are left for 5 to 6 minutes. These are all the properties of the solution. These are very important properties of the solution. They may ask in your examination for 3 marks. You have to remember these properties. In your examination, they may going to ask you a question in a combined form, like what are solutions, write the types of the solution. That is, types of the solutions are nothing but solid liquid solution, liquid gas solution and gas in liquid solution, and write down the properties of the solution. What are the properties of the solution here? A solution, it is a homogeneous mixture. As I told already in the definition of the solution, it is a homogeneous mixture. That is the first property of the mixture. So if it is a homogeneous mixture, then what are the conditions to say the mixture it is homogeneous? The particles of the solution cannot seen by the naked eyes. If and only if a mixture contains the components, if it is said to be a homogeneous, if and only if it is completely dissolved in it. If it is completely dissolved in it, we are not going to see the particles which are dissolved in the mixture, then only we are call it as a solution. The second property of the solution, it is nothing but the particles of the solution cannot seen by the naked eyes. And the third property, it is a solution does not scatter a ray of light. When you are going to pass the ray of light into any solution, it does not scatter. If it is not a solution, the particles are not completely dissolved in it, then you are going to say the scattering of ray of light when you are going to pass the ray of light through it. And another one property of the solution here, the solute particles cannot be separated by the filtration. Yes, so solution, the solute particles, they are completely dissolved in the solvents. That's why we are not going to separate the solute particles which are dissolved in the solvent in the solution by the filtration process. And another one property of the solution here, the solute particles do not settle down if you left undisturbed. So when you are going to left undisturbed a solution, the solute particles which are dissolved in the solvent, they are not settled down. Why? Because they are completely dissolved in it. So these are the important properties of the solution. So based on the amount of the solute particles dissolved in it, the solutions can be differentiated, or the solutions can be classified into 3 types. The solutions can be classified into 3 types based on the amount of the solute dissolved in it. Those are nothing but concentrated solution, dilute solution and a saturated solution. Based on the amount of the solute particle dissolved in it, we are going to classify solution into 3 types. Those are, first one is concentrated solution. Concentrated solution. Concentrated solution. What is concentrated solution here? A solution in which amount of solute dissolved in the solvent is more than the solvent, then this solution is said to be concentrated solution. Is said to be concentrated solution. So see here, what is a concentrated solution? A solution in which the amount of the solute dissolved in the solvent is more than the solvent. The amount of the solute particles dissolved in the solvent is more than the solvent. I am considering one example here. If 10 grams of grams of sugar dissolved in 8 ml of water, 8 ml of water, then it is a concentrated solution, concentrated sugar solution. What is the mean here? If a solution, it is said to be a concentrated if it has the solute particles, if the dissolved solute particles, the amount of the dissolved solute particles is more than the amount of the solvent. Here I am considering one example here. 10 gram of sugar dissolved in 8 ml of water, that is the solute is greater than the solvent. Solute is greater than the solvent, then this solution, it is called it as a concentrated solution. Is it clear? What is concentrated solution here? A solution in which the amount of the solute dissolved in the solvent is more than the solvent, then this solution, it is called it as concentrated solution. Then what is a dilute solution? What is a dilute solution? What is dilute solution? See here, that is opposite to the concentrated solution. Dilute solution. Dilute solution. It is a solution. A solution in which amount of solute dissolved in a solvent is less than the solvent, then this solution is called a dilute solution. Then this is said to be a dilute solution. A dilute solution. See, what is dilute solution here? A solution in which the amount of the solute dissolved in the solvent is less than the solvent. The amount of the solute dissolved in the solvent is less than the solvent, then that solution, it is called to be a dilute solution. For example, I am taking similar example here. 5 gram of sugar dissolved in 100 ml of water, then this is a dilute sugar solution. Here see here, 5 gram of sugar, this is the solute. The amount of the solute, it is less than the amount of the solvent. The amount of the solute is less than the amount of the solvent, then this solution, it is called it as a dilute solution. Simply, what is concentrated solution here? If the amount of the solute is greater than the amount of the solvent, then the solution, it is called it as a concentrated solution. What is dilute solution? If the amount of the solute is less than the solvent, then that solution, it is called it as a dilute solution. Another one type of solution we are going to see here, it is that is saturated solution. What is saturated solution? Saturated solution. Saturated solution. Under one type of solution, saturated solution. Saturated solution. When a no more solute can be dissolved can be dissolved in a solution at given temperature. It is called saturated solution. See, what is saturated solution here? When no more solute can be dissolved in a solution at a given temperature, it is called saturated solution. Consider some 100 ml of water in a small beaker. Add 5 gram of sugar into it and dissolve it. After 2 to 3 minutes, the 5 gram of sugar will be dissolved, and continue the process about 10 to 15 times. At one end, you are going to see the sugar particles cannot be dissolved completely in the water. Why? Because the amount of the sugar particles that cannot be dissolved in the water, at that condition the solution, it will be said it as a saturated solution. What is saturated solution here? When no more solute can be dissolved in a solution. So every solution has a capacity to dissolve some solvents in it. So at the one end, at the one time, the capacity of the solvent, it will be complete, it will be filled up. At that time, at that condition, the solution can be said to be a saturated solution. So what is saturated solution here? When no more solute can be dissolved in a solution at a given temperature, it is called to be a saturated solution. So in this session, we are studied under the chapter is matter around us is a pure. What are pure substances? What are mixtures? What are the types of the mixture? What are homogeneous mixture? What are heterogeneous mixture? What is the solution? What are the types of the solutions? That is concentrated solution, dilute solution, and saturated solution. In the next session, we are going to continue the continued part of this lesson. Thank you.